What's happening, y'all? Let's look at section 5.9. Start to take a peek at what's going on here. It's called polynomial modeling, and we've done polynomial modeling. Anytime you do a linear regression, the linear is degree 1 polynomial, or quadratic regression, degree 2, or cubic regression, degree 3. We've done those regressions. It's under stat calc. We've done all those different regressions, and those are polynomial models. So we have this section polynomial modeling that's going to kind of sum up what we're talking about here. And I'm going to put some points here and just kind of randomly, I'm going to make them so that they're basically in a straight line though, so that a straight line will be a good model for them. But they're a little bit off. You know, when you collect data, it's always going to be a little bit off. If anyone collects data and it comes out perfectly, they're lying. They fudged the data. So know that don't trust anyone with perfect data. They're lying. Okay, so I'm going to create a list. And now we have list 1 is all of my points, and I'll need that in a minute. So I have all these points here, and if I actually have real data, I could have typed them into my input bar here and done something with them there. So I have my list, and I want to fit a polynomial to it. But first, I'm going to need a slider here. And what this is going to do, it's going to let me change. You know, in our TA83, when we find different regressions, we have to go through the menu and it gives it there. With GeoGebra, I can change the degree on the fly, so we can see it change immediately, which is kind of cool. So fit poly, and if you are watching this at school and not home, it says fit poly. You have the list of points and then the degree of the polynomial. So that's what I need to tell GeoGebra. Well, the list of points is list 1 because that's what GeoGebra called it. GeoGebra called it list 1. And then the degree of the equation, I want that to be n. And whatever this value of n is, it'll recalculate a new line for me. So let's hit enter. And the current degree is 1. So 1 is a first degree equation, polynomial, which is just a straight line. Okay, so I can see that the function, I have to kind of scooch it over there. There it is, 0.73x plus 0.22. So that's a first degree equation. And we'll keep an eye on the leading term there. And I can go all the way up to, let's see, 13th degree equation. You can see it actually is 0x to the 13. That's probably rounding off. It's probably 0.000 something. But you have something to the 13th power. It's a 13th degree equation. In fact, I'm kind of curious about that. Trust me, it's not 0, it's something else. So we have all of these points here. And you'll notice that at the 13th degree, it goes through every single point exactly. So it fits all of those points exactly. That's kind of cool. As I go to degree 1, even though it gets close to the points, I don't think it goes exactly through any of them. So degree 2, that would be a quadratic. Degree 3, that's a cubic. 4, a quartic. 5, quintic. And I don't know about 6 and so on, but they're all there. And if I go up to, again, to 13, that will go exactly through every point. Let's see here. In between B and I, though, do we really think that the graph is doing this? If I was measuring, I don't know, some correlation between, I don't know, wind and temperature, I think that the data would actually, I think that a linear fit would probably fit this data a little bit better. I think if I took a measurement at 1.7 or so, it'd probably be closer to there than all the way up there like the graph was. So just because you can do a larger degree doesn't necessarily make your model better. Now notice that at 14, I lose the graph. Okay, GeoGebra gives up, you can't do it. Whoops. That's because 13, let's see, how many points do we have? A, B, C, D, E, F, G, H, I, J, K, L, M, N. So that's 14 points. I know J is the 10th letter. So 1, 2, 3, 4 more. 14 points. I can only have a 13th degree equation. So there might be some relationship there, okay? If you have 14 points, you can only have a 13th degree equation. That's always going to be 1 less. So if I had 20 points, I can only have a 19th degree equation. But that equation right before, like 14 point, 13th degree equation is always going to go right through every single point. Okay, so if you need a graph to go through every single point, if you have 20 points, you'll do a 19th degree equation. If you have 100 points, you'll do a 99th degree polynomial. It doesn't necessarily mean it'll be better or more useful, but that will give you a line that will go exactly through them. Okay, but all the way back to 1. I like this one the best. I think this models the data the best. Maybe a quadratic, but I'd need a little more proof that it was going to be curved like that. So that's a little bit of an introduction into polynomial modeling. Woo!